numbers.
Okay. How does what? Well, I do the school's exemptions. And my second year kids, they've already taken their finals. Yeah, the school, the policy, same thing has been the last 2-3 years, which is ridiculous, but anyway.
What's the exemption?
Don't you worry about it.
Oh.
Just kidding. No, it's like, oh, you guys, if you're juniors, if you pass all parts of the tax test, I think you're exempt as long as you don't have over 3 absences.
Oh, like in class or like?
In that class.
Oh. I think I have I got like 30, 50, 60, 70, 90.
And I think they have to be, I mean, school absences don't count. UIL stuff, I don't think. But I don't know. Guys, you all know that? The UIL absences, they don't count, do they?
They haven't told us.
I wouldn't think that way. That'd be ridiculous. Then nobody would do sports. Yeah.
They have to do like skipping or just.
Also like.
Yeah, I think, does a doctor's absence count? I don't know.
So
I'll
like,
find out. My guess is,
so we'll have the tax test results by the day?
say it again?
We'll have the tax results before the...
Yeah. I'm guess is they'll have them in about a week.
And then if we pass it, then you don't have to take it, or?
You have to pass all courses, and then you don't have to take the core classes. The 4 core classes.
From last year.
All right, guys, you ready?
Yeah.
Didn't we take? Oh, he took them all. I remember getting it. Yeah. I remember I don't.
Isn't the rain good, guys?
Nope.
The great thing is to start, it's raining a lot in our drainage basin for our lakes. I mean, you realize the fact that it rains here doesn't make a difference at all in our lakes, does it? Our lakes, but it's raining at Thomas, it's raining for Spence, it's raining Lake Ivy.
At least it helps our trees survive for like 3 more days.
Do what?
Yeah.
It's nice and cool compared to a week ago, isn't it? And that's really weird. What happened was the gesture went down from like Canada down to here. When that happens, it gets cooler. We ready, guys? Let's go through this, okay? All right, mouth shut, pay attention. First thing, resistors in parallel. Ours in parallel have the same voltage drop. We just went over that, right? Ours in series have the same what? Current. Here's the difference. And what I'll do is, not tomorrow because I won't see half you guys tomorrow. On Monday, I'll give you a worksheet that does both of them, so you can view them both and compare them. And then we'll have a quiz on Tuesday. When do you guys take your English test? Wednesday? Thursday. Is Wednesday? Okay. So I'll shut down for Wednesday too. All right, guys. Ours and Pro have the same voltage drop. The currents will be different, assuming R1 is not equal to R2, which is not equal to R3, which is not equal to whatever. How many R's did you have? Is everybody clear?
Yes.
All right, and then equivalent resistance for R's in parallel is that right there. I could derive that for you, but I don't want to take the time to do it. Although I'll do it in years from now, like next year, because we have time. I just didn't do it. But it is true, and it's different from in series. You add them, don't you? Here, it's just a different kind of formula. Guys, what are you doing?
Well, fly. It's not even mouse.
Fly. Yeah.
What happened to be big?
The mouse flying no doubt. Okay, guys, with that in mind, let's do this. Once again, why do we do the why? Guys, forget to fly. Why do we do the REQ in the first place?
That's how
In a sense, to get the total current. Because once you have the REQ, you can always get the total current, right? As long as you know the voltage. All right. Now let's do example. Guys, draw that, and we're going to do. By the way, don't get hooked on the form. In other words, I can take this circuit and put it like that. It's the same circuit, isn't it? Then the battery would be over here, right? The current resistor would be here. Don't get hooked up on how it looks. Understand what it is, okay? All right, draw that, write that. We're going to do it. We're going to find out the RQ, the total current, then the current in each resistor. And then we'll do one more thing, and then I'll give you a worksheet, and then you get your work done. And I'll kick back and take it easy. I'm a sorry teacher. You know, I was thinking, Christine, you need to get you one of those hats like they have. Have you ever seen the Broadway show Chorus Line? Anybody know what I'm talking about?
Nope.
Have you seen the last commercial for the Texas Library where they're doing like a show routine? All that cash? Do you watch TV at all?
TV. Wait, what's this TV you talk of?
That last, what's this TV you talk of? Is this a new thing?
Sure.
Yes. They just invented it yesterday.
I bet you could just draw it. The hat you're talking about.
Oh yeah, you can
Just I'll show you online. How about that? Guys, now my resistors do not look very good, do they?
Nope.
I mean, in reality, you know what they're supposed to look like, correct? Because they're on the sheets that I give you. Well, I don't get too hooked on as long as I know you know what it's supposed to look like. Okay. Everybody ready?
Yes.
I'm going to ask you just one simple question. It has nothing to do with this. I just want to see if you know, because I've told you. The current right here across the battery, is it going that way or that way?
That way.
That way. You got it. Goes from negative to positive, right? I'm proud. Very good.
Positive to negative.
It always goes from the negative to positive pole through the battery. Because you put voltage into it, and when you go from positive to negative every time. I'm sorry, from negative to positive. All right, guys, so let's do this. Let's get the REQ. So, I need to change REQ. It's going to be R3 plus 1 over R4 plus 1 over R6. And my subscripts just represent the resistance. Let me pop this up so you can see what I'm doing. Voila. Get this out of the way. And we're going to put it here. Okay, so let's plug in numbers. Guys, there's all kinds of ways to do these. If I can get a common denominator, I do that. If I can't, I just plug it into the calculator. You know what I mean? What's the common denominator for this? You got it. So 1 over REQ. We're going to solve for REQ, of course. It goes 4 over 12 plus 3 over 12 plus 2 over 12. Which gives you, 9 twelfths? 9, 3 twelfths. Now that's not the REQ because it's 1 over REQ equals that, right? So therefore REQ equals 12 ninths, which equals 1.3 ohms. That's your REQ for the whole thing. 1.3 ohms. All right. Any questions on that, guys?
You just confused him.
Do what?
You confused him very.
How?
Why did you flip it?
Because 1 over REQ equals 9 over 12. All right. Certainly a little bit there.
He's confused.
Now he's enlightened. It's a wonderful life, isn't it? It's tough to go through life with blithering idiot. But, I guess it's not because you don't know it. You're an idiot.
Thank you for sharing.
What? It's just my pearls of wisdom, right, Esteban? All right. Okay, is everybody good? Now, let's do what's the total current. So anytime you have the REQ, I don't care whether it's in series or parallel, once you have the REQ, then you do V equals IR to get your total current, right? V, and that's what I'm doing here. In other words, this circuit equals this circuit, where this is 1.3 ohms, right? See that? And then I get my total current by what I have written up there. Everybody good? Just like I did the other day, different REQ, different method of getting the REQ. So by that, then I get the total current, right? Any preguntas? Okay. Let everybody get that written down, then we'll get the last part done. The last part is to get the current in every resistor. And we're going to verify something once we do that, okay? We'll get the current in every resistor.
So what's different between today and yesterday? We're going to find the current in each resistor?
Well, we're still going to do, you get the current in the resistor, you get the total current, we're still going to use the REQ, right? But we derive the REQ a different way, didn't we? There are other differences, and that's where I'm going to show you. When we do this, it shows some more differences, okay? We will, once again, if I didn't already tell you, we're going to do a worksheet Monday that does resistors and parallel, so you can see the difference as you're doing it. And that's where guys really get confused. Is it hard? No, but guys do brain locks on me. Mr. Brett, help me out here. Sorry. And I can usually tell, by the way, those that do good on that quiz are good at physics. I've always, it's patently true. They just see it. You follow me? Sometimes I have to explain it once, but they get it. Those who are actually not good at physics, they'll make a mistake after mistake after mistake. And I can show them, and they'll get it. But when they do it themselves, they'll make a mistake again. You'll see what I mean? And you'll say, Mr. Brink, I'm just not a physics person. Or you'll think, Mr. Brink, I'm a stinking genius.
I will think both.
Huh?
I will think both.
All right, guys. Now, is everybody looking up down here? Now let's get the current in every resistor. By the way, when I have the current in this resistor, what should it add up to?
9.
It should add up to the total current, right? That was not true with resistors in series, was it? The total current was the current in every resistor, was it? Is everybody clear? Because they're back to back to back. This is not the case. All right, guys, let's do this. What's the voltage in the 3 ohm resistor?
9.
Yeah, they are all 9 volts, aren't they? This. They're all directly connected to the battery. They don't go through another resistor. Or the current does. So 9 volts for each one of them. And let's see. Just put the ohmage of each resistor there when you know it just by looking at the subscript. Okay. It's going to be 3 amps. It's going to be 2.3 amps if you round it. It's going to be 1.5 amps.
Close enough.
Yeah, the total equals what? 6.8 amps, which is darn close to what we got on the when we did the REQ, right? Why is it off by a hair?
You round it.
Rounded. That's all it is. It's all just rounded. Because we rounded this one here big time, didn't we? I mean, some anyway. Now, guys, let me ask you a very simple question. Do you get the bigger picture? Don't ever just do monkey see, monkey do in physics. I'll nail you eventually, you know what I mean? And you try to get on testing, you're just trying to repeat what I'm doing by plug and chug. This next quiz comes up, it will kill you. Okay? All right. Very good. Let me get the worksheet out to you.